Welcome to the talk, everyone. My name is Tshepo. By way of introduction, I'm a co-founder and a data scientist at Ashanti AI. I'm also a consulting data scientist at Anglo American. I'm going to be talking today about a topic that got me interested and involved in the world of data science, comparative data science. So in my presentation, I'm going to be talking about the structure of the competitions. How are these competitions structured? What kind of problems or kind of data sets you should be looking forward to taking part in, and also my way of processing that data and how I build and optimize my models. First and foremost, why do these competitions exist? So companies use this platform or method as a way to crowdsource data science skills from all over the world. And these competitions are open to everybody who is interested, all the way from beginners to experts. So now reasons for you to participate. The first reason that I benefited from the most personally was that you gain specific knowledge that is hard to attain or automate. And also you explore different kinds of problems in all different fields. If you're in the mining industry, you get exposed to challenges in HR or challenges in the insurance industry. And also you get these skills that you get here are transferable. So how you learn to build models for these competition, you're also gonna apply those skills to building models for deployment for your particular company. And if those three reasons are not enough to convince you, there's a cash prize for the top 3 people on the leaderboard. So now the kind of data set you should look forward to when taking part in these challenges, the most common one would be your tabular data. It's nicely structured. You have your rows and your columns, and the Python packages that you would use to interface with the data is pandas and NumPy. Right now, moving into the realm of unstructured data, you're gonna get text data. So with text data, I use NLTK to transform the data from text to numeric features so that I can train my models. Sometimes I also use Spacey to visualize the interactions between the name entities. And also another one is images. So for images, there's actually a running joke in the community that cats and dogs classification is the hello world of building classification models for image. So you can use scikit-learn and OpenCV for that one. And lastly, the one that consumes a lot of memory is sound data. So for sound data, I took part in a competition where we identified the name of the bird according to the song it made. So you can use SciPy to get these kind of visualizations from your data to visualize the waveforms. So there are various problems that you can get when you're taking part in these online data science problems. So I'm going to focus on mainly the most common ones, classification and regression. So for classification, you're building a model that's going to classify whether your data set belongs to the blue dots or the orange dots. So the model that you see visualized here with a nice soft decision boundary, there's a neural network that separated the dots according to their colors. So the top triangle is for blue dots, the bottom triangle is for orange dots. So now you also need to be aware of what the competition uses to score you, like what kind of metric they use. Most commonly, they would use an accuracy. I've taken part in challenges where they also used AUC. So here you're optimizing to get a score as close to 1 as possible. So 60% for accuracy would mean your model is 60% accurate. If it's less than 50%, it means that your model is worse off than just random guessing. So you can just flip a coin and decide which one of the classes that model belongs to. You're going to perform way better than that particular model that was built. And the type of data you would get for this kind of challenge, it's everyone that I visualized in the previous slide. So your text data, tabular data, images, and sound. So now the next problem that you're going to find is regression. So here you're not predicting a class, but you're predicting a continuous variable, right? So you're trying to model the relationship between inputs and output. For example, your input could be the weight of a car, and then the output could be fuel consumption. So the model then would say, for this weight, I predict that it's going to consume this amount of fuel. So the score that the metric that they normally use on these competitions, it's MSC. Sometimes they also use root mean square. So root mean square is just the square root of MSC. So that's how we get those metrics from Python. And the type of data, text data and tabular data. So tabular data goes without saying, but with text data, I've taken part in a challenge where you had to predict the retweets of a tweet. So it's text data, and then the target variable is the number of retweets the tweet got. So now you're just predicting for the next tweet, how many retweets it's gonna get. So you're basically predicting interaction for particular tweets. So the kind of platforms that I use to take part in these challenges by my personal preference is Kaggle, Zindi, Analytics Video. So for Kaggle, I like it because it has kernels where you can access your data set online, do your data analysis, build your models, and then submit your results online. Right? For Zindi Analytics Video, you have to download the data and work locally. And also with Kaggle, when you taking part in competitions that has a large data sets, you can use the GPUs and TPUs that they have for you, or you can host your own competitions on those platforms. So my typical pipeline when I get when a new challenge is load and Kaggle sends you an email that, hey, there's an interesting challenge up. So I understand, I take time to understand the business case. I'll go through the descriptions, like the company that's posting the problem. What do they intend to do with the model? And like, why do they have that problem? And most important question is, can this problem be addressed with machine learning? Right? Some problems, they don't necessarily need machine learning. They just need a good EDA, and then you can send your predictions, and then you get a perfect score. But like most of the problems they send there, they would need a machine learning solution in the first place. But it is best not to assume. So after I'm done with the business case, and then I'll do my EDA, I do my data cleaning, I do my feature engineering, and then I'm going to train my baseline model. Normally it's XGBoost. Then I will do my validations, and then do my hyperparameter tunings, validation, and then submit my predictions and get my score and my rank. And now the extra things that I'm going to do after that pipeline is complete is I'm going to explore model staking. I'm also going to explore building different models and then averaging the results and then submitting those for a better score. So exploratory analysis, I tend to think of it as you taking the problem on a date. You need to build intuition about the data, ask it questions to get to know it a little bit better. So the more you understand the data, the more you understand the problem as well. So with data analysis, you need your visualizations plotted in line. Your classical editors, they would print out your visualization in a new window. You don't want that. So I normally just use Jupyter Notebooks for that. And for analyzing my data frames and my arrays, I normally just use Pandas and NumPy. So you're good with those. And for the visualizations, I just go to Matplotlib and Seaborn. But there's other ones if you're interested. If you want to build interactive dashboards, you can use Plotly for that. So the first thing that I like to do is get a good understanding of how the data was created, and also understand the relationship between that data and the test data. How are they related? So the column that you would use here is the ID column, right? So you can see here it increases consecutively with 1. So I can tell that, okay, the first one was created, and then the second one, and the third one, all the way to 1,460. And now when I look at the head of my test data, it starts with 1,461, and then the test data ended at, the train data ended at 1,460. So I can tell it's a continuation, and then I see that the test data ends at 2,919. So this just tells me that they had a data set of about 3,000 instances. They split it in half for training and testing data, and most importantly, it was not shuffled. So I would have to shuffle the data. Sorry about that. I have to shuffle the data to remove the biases that would introduce to my model, so that my model could have a higher quality. Right, and on the next tab is to identify missing values and duplicate values. So I normally just like to put it in a heat map from Seaborn, and then the lighter spots there indicates the missing entries, the darker spots, those are the filled out ones. So I've highlighted about 5 columns. You can see they have a lot of missing entries. The one that I've highlighted there is Ellie. And then now I get the count of those missing values. I can see that Ellie has got 1,369 missing entries from 1,460. So now the next step would be for me to see how many unique entries each feature has. You can see with Ellie here, it has only 2 unique features. So it's not going to be helpful when I'm building the model. So I already understand that. So another thing that I like to visualize is to understand how my numerical features and my target variable are related. So I would plot a thing called partial dependence. It is just fancy word for plotting your target versus your numeric, right? It's just a scatter plot. So it gives me the opportunity to see, okay, cool. I'm looking at the sale price at the bottom, and then the year the house was built at the top. So this data set is for predicting the sale price of a house given its various features, right? So here, this is my target variable. This is, a feature when the year was built, and I can tell that the houses that were built most recently, they are on the higher end of the spectrum in terms of the pricing, right? And also the year remodeled, same thing. This is the target variable. That's the year the house was modeled, and the ones that are remodeled recently, they fetch higher prices than the ones that were remodeled like in the 1950s. So I do that for a number of features just to get that understanding. Now for data pre-processing, you need to pre-process your data with regards to the model that you're planning on building. So in a way, you need to start with your end. You need to begin with the end in mind, right? So if you're going to build a linear model, it is imperative that you standardize your data. You can use a min-max scaler. You can use a standard scaler. So a min-max scaler will just take your feature and then return values between 0 and 1. That's all it does. All of the data are going to be, all of the features are going to be standardized to that. It's between 0 and 1, so they're going to be more consistent. And standard scaler is just going to take your feature, whatever distribution it is going to remain a Gaussian distribution. It's going to return a Gaussian distribution for you. So now you've taken care of the outliers, and your linear models are highly vulnerable to outliers. So with neural nets, it helps to perform a log transform. So log transforms, what they do is they make your features less skew, right? And also, like, they're good for your data analysis. Like if you're plotting two features and there's no discernible patterns, and then you do a log transform on them, you can see actually the pattern starts to emerge. Or you can just raise the features to the power less than 1 using that equation, or whichever one you like. So now that I've identified that I have missing entries, what is it that I'm going to do about it, right? So there's a rule of thumb that says that if you have 15% or more of missing entries in that column, you drop that column, right? But I tend to disagree with that. Try to reconstruct the data, or if you can't reconstruct the data, it's utterly useless. Try and then capture the missingness pattern of your data, right? So because data could be missing for various reasons. It could be missing at random. It could be missing because of equipment failure. It could be missing because equipment was not calibrated properly. So you can capture that by creating this column here. So this is garage conditions. It has three categories, and then there's 2 missing ones. So the column that I created was garage C missing. So if the entry is missing, it's a false. If the entry is missing, it's a true. So it's going to capture that relationship of the data that was missing, the patterns where the data is missing. And also this column will help me because it's 100% filled. Now, recently I worked on a project where I had to get data from SAP, and then it didn't have salary data for contractors. It just had salary data only for full-time employees. So here, the general strategy that you would get is fill in the missing values with the average of that column. I would advise against that. Rather, fill in those missing values with the average of that particular category, right? So these are different branches of engineering. So for civil engineering, the average for the column is 57,000. So it's going to give civil engineering 57,000 here. If you look at civil engineering, this guy, it earns about 48,000, that one 45,000. So you can agree that 46,000 is way closer to 45 and 48 than 57 is. So try to do this approach. It's going to improve the accuracy of your model. And then outliers. So with outliers, there's 2 strategies to deal with them. Look at this feature here, this miscellaneous values. So you can see most of the data are leaning towards the left. So there's closer to 0. And then you have 1 popping up there at 8,000 and 15,000. So there's an approach called winsorization. So what it does, it clips the outliers. It more or less maintains the essence of the distribution of your data, but it brings them closer to each other. And then you can also use rank data from SciPy. It operates the same way. So now feature engineering for numeric variables. Like I said, for your learning, for your linear models and also the KNNs, it's important that you scale your data and also you clip your outliers. Now for tree-based models, so there's a feature called weight. So what I do is I'll take the floating point of 57.75 and then create fractional weight from that. So now you're creating another new column, 87.93, 0.93. So you've created a new feature from the existing feature, which will increase, it'll give you a slight edge in accuracy scores. So these strategies work for both tree-based models and also neural nets. Now you can also take advantage of the interactions between your variables, right? If you have access to horizontal and vertical distances, you can use Pythagoras theorem to get this column. And now, you created a new feature from two different features, right? Or also you can combine them. Say, for example, for predicting prices of houses, you have your area data and your prices. You can create a value or a column called rents per meter squared. It's combined from area and also the price of the house. So it's just the price of the house divided by the area of the house, and then you would get that value. And feature engineering for categorical variables. So what I used to do here, one hot encoding, it used to be my Thor's hammer. I would hammer at every column that had categorical variables. For example, here you have provinces. You have Gauteng province, Northern Cape, Northwest, and Northern Cape again. So this column relates to GP because it has a 1 at GP, zeros at those other two. And then this column relates to Northern Cape because it has zeros there. So I used to take this approach and then do it on all of my challenges. The problem with this, anybody who has done it will tell you that once you have about 50 provinces, now you're just gonna feed your model a sparse matrix full of zeros. Another approach that you can take is using categorical encoding. So what happens here is because GP is the first entry in the data set, it's gonna get a 0. Northern Cape gets a 1, Northwest gets a 2, Northern Cape already got a 1, so it's a 1 here. Or you can also use frequency encoding. So it's just gonna encode your category according to how many times it appeared, right? So the GP appeared only once, it gets a 1. A Northern Cape appeared twice in the column, so it gets 2. A Northwest, it got a 1. So you can choose between these two strategies and see which one works best or to your advantage. So now coming to the interesting bit, our models and hyperparameter tunings. So the same way you process your data with the model that you're thinking of building, like if you're gonna build a tree-based model, you have to process your data a certain way. The same thing applies here. So I normally use XGBoost and LightGBM. Sometimes I would use CatBoost because it accepts missing value. If you don't want to deal with missing values, you can just assign the parameter that says, okay, this column is missing, so and then it will handle it accordingly. So if you're building classification models for images, then I would just use Keras. They already have weights for deep learning models that are already pre-trained for you to use them. So when I'm doing my parameter tuning, it's important to group those parameters according to what effects does it have on your model. For example, the features that I have here, max depth and num leaves, they're all similar. It's just that they're named different for XGBoost and also LightGBM, right? So these particular hyperparameters, they make your model more complex and therefore overfit. So max depth, that's the depth of your tree, right? So it makes your model more complex and then the model will overfit. Subsample or Bayesian fraction, it's how your model would randomly select part of your data before building a tree. So if it's a larger number, then obviously your model is going to be complex and overfit. Call sample and also feature fraction. So this number, if it's less than 1, say for example, it's an 80%, your model is going to sample 80% of your features before building a new tree. ETA, num run, and learning rate, like I said, they're all similar. So ideally, you want a small learning rate with a high number of iterations. So that will also make like your model overfit just a little. Now for the parameters that make your model underfit, mean child weight and mean data leave are similar. This is a value that you set to stop partitioning of the tree. So the larger value, this one, it makes your model more conservative. So therefore your model will underfit. And number 2, lambdas and alphas, those are just regularization techniques. So they will make your model underfit as well. And for neural nets, your number of neurons, your number of layers, and your batch size the larger those ones are, obviously your model is gonna make better decisions because it's more complex and it will overfit. And also your optimizers, your adaptive learning there, they make your model overfit. So for stochastic gradient and momentum, they're related. So momentum speeds up your gradient descent. They would make your model underfit. So now when it comes to model validation, you need to make sure that your model gives you the expected scores, right? So what I do is I take my training set, I shuffle it, and then I split it into 90 train and 10% validations. And then I train my model, and then I get my score, and then I use 100% of the training data to train my model, run it, inference on the test data set, and submit. And then my score on the leaderboard should be more or less similar to what I got on my validation score. Otherwise, and then your model will either be overfitting or underfitting. Right, so the summary basically of my presentation is that biased models are dangerous, right? So for online challenges, you're gonna give that model to a certain company, and then they're gonna build a model and deploy it. If the model is biased, it's gonna have unintended consequences. For example, Amazon's recognition. Anybody who heard of that would know, right? So the most important thing that I've taken away from taking part in these challenges is that it gave me the necessary experience and skills, and also the confidence that I needed to take part in more challenging and groundbreaking challenges. For example, Zindi is hosting this challenge where you have to use machine learning to come up with a cure for leishmaniasis. This is new and unbroken ground, and I feel confident in the fact that I'm going to take part. I'm taking part in this challenge, by the way. I'm going to learn a ton. So yeah, that will be it from my end. I thank you for attending. I will see you in the Q&A section.